afternoon, students. This is Aravind, Assistant Professor, Department of Chemistry, DBSIT, KAVALI. So in the previous class, I discussed about some numerical problems on parallel operation of alternators. And now in this class also, I am going to discuss some numerical problems on parallel operation of alternators concept. Okay, firstly, I will take the class on numerical problems. So in this one. So actually in the previous class I discussed about 3 problems, and now in this one I am going to discuss few more problems on parallel operation of alternators. So coming to the problem, so here they given a 2-pole 50H 3-phase turbo alternator is excited to generate the busbar voltage of 11 kV on no load. So the machine is stock connected and short circuit for its excitation is 1000 amperes. To calculate the synchronizing power per degree of mechanical displacement of the rotor and corresponding synchronizing torque. So this is the given problem. So by using this problem, we have to determine the synchronizing power per degree of mechanical displacement of the rotor and corresponding synchronous torque. Okay. So firstly, we will write the given data first. So in the problem, they already given the number of poles is 2 and the frequency is 50Hz and the phases is a 3-phase alternator. So it consists of busbar voltage, that is the E or that is equal to V. So E is equal to V is equal to V, that is equal to 11 kV. That too on no load. So the given no load. So actually it is a 3-phase system. So that's why I am converting this 3-phase voltage into phase voltage, single phase voltage, that is E phase is equal to V by root 3. Actually the formula is V by root 3. So here E phase is equal to E by root 3. So here E is equal to 11 kV. So that is 11 into kV means, that is kilo means 10 cube, that is 11 into 10 cube by root 3. So after simplifying this one, we have the value that is 6350.85 volts. That is the EMF per phase or voltage per phase. And next they already given that the short circuit current IS is equal to 1000 amperes. 1000 amperes. By using this data, we have to calculate the synchronizing power and synchronizing torque. So you know already the formula to calculate the synchronizing power, that is P suffix S5 is equal to E into IS into delta dash. E into IS into delta dash. So just now we calculate the E value and IS already given. So next we have to calculate the delta dash value. So to calculate the delta dash value, you know already that is delta dash mechanical is equal to 1 degree. So 1 degree is equal to pi by 180. 1 degree is equal to pi by 180. So if you convert this mechanical degrees into electrical radians, we have the formula that is delta dash electrical, that is equal to P by 2 into delta dash mechanical. So already we know that delta dash mechanical is equal to 1 degree, so that is equal to pi by 180. And in the formula, in the delta dash electrical formula, we have the P, that is number of poles. So actually in the problem, they are given the number of poles, that is 2. So substitute here, that is 2 by 2, that is P by 2. So already 2 is there and the number of poles is also 2. That's why I am taking 2 by 2 into pi by 180. This pi by 180 is the delta dash mechanical. So that is equal to, finally we have pi by 180 radians, that is electrical degree. Pi by 180, delta dash electrical is equal to pi by 180. So you know, you already just now determined the delta dash value. So take the synchronizing power. The synchronizing power P suffix S5 is equal to E into IS into delta dash. So you already know the E value and IS value, and just now we calculate the delta dash value. Please substitute those values into this equation, this formula. So that is E is equal to 6350.85 into IS is the short circuit current, that is 1000 into delta dash is pi by 180. So finally we have the 11th of 1,08,043.24 watts, that is 110.843 kilowatts. And total synchronizing, we have to calculate, so total synchronizing power, that's why I am taking P suffix S5 is equal to, it is a 3-phase system, they are already given in the problem. It is a 3-phase turbo alternator, that's why the total synchronizing power P suffix S5 is equal to 3 into PSY. So that is 3 into, just now we calculate the synchronizing power, that is 110.843 kilowatts. So actually here, and now we have 332.59 kilowatts. That is the total synchronizing power in the three-phase alternator. And next, we have to calculate the synchronizing torque. So we know already the synchronizing torque form, that is tau Sy is equal to P suffix Sy by 2 pi n s by 60. This is 2 pi n s by 60 is equal to omega. That is the angular frequency. So here I am taking 2 pi n s by 60. So we know already PSY, there is a synchronizing power value we already know, and 2 pi 60 is also known, but we have to determine the synchronous speed, that is Ns is equal to 120 f by P. So in the problem they already given the frequency, that is 50. So substitute here, that is equal to 120 into frequency 50 divided by P is number of poles. In the problem they already given number of poles is 2. So substitute here, finally we have the synchronous speed, that is 3000 rpm. So next, we have the total synchronizing torque, that is equal to total synchronizing power divided by angular frequency, that is 2 pi ns by 60. So total synchronizing power, just now we calculate, that is for the three-phase system, that is 332.52 kilowatts into, that is the kilowatts is 10 cube divided by 2 pi into ns by synchronous speed, that is 3000 divided by 60. So after simplifying this one, we have 1058.4 Newton meter. This is the total synchronizing torque for the given system. Okay, this is the solution for the first problem. And coming to the next, that is a 3 MVA 6-pole alternator runs at 1000 rpm in parallel with other machines on 4.44 kV bus bars. The synchronous reactance is 20% and calculate the synchronizing power per 1 degree mechanical displacement. So by using the data, we have to calculate the synchronizing power per 1 degree mechanical displacement. So firstly we have to note down the given data from the problem. So from the problem, the given data is already given. The MVA rating of the machine, that is 3, and the poles is 6, and the speed is 1000. And it consists of the voltage rating, that is 4.44 kV, and we have synchronous reactance, that is equal to 20% of the bus bar voltage. Okay, so that means first we have to note down the V is equal to 4.44 kV. So actually it is a three-phase alternator, and then we have to convert this load voltage, line voltage into phase voltage, that is V phase is equal to V by root 3. So that is equal to V means 4.4 kilovolts, that is 4.4 into 10 cube by root 3. So that is equal to 2.5403 kV. So we will also assume this one as 2540.34 volts. So in the problem they already given the synchronous reactance drop Ixs is equal to 20% of the voltage, that is 2540.34 volts. Then in the problem they already given the MVA rating. So you know already the formula, that is KVA is equal to root 3 by V in the IL something, root 3 into VLIL. So by using this one we have to write IL is equal to MVA rating by root 3 into voltage. So here MVA rating is a 3 MVA, that is a 3 megavolt ampere. So mega means 10 to the power of 6. Substitute here, so that is 3 into 10 to the power of 6 by root 3 into voltage is 4.44 kV, that is 4.4 into 10 cube. And after simplifying this, we have 393.64 amperes, that is the line voltage, so the line current of the given machine. So you know already the formula MVA rating, that is MVA rating is equal to root 3 into VLIL. So from this one I am writing IL is equal to MVA rating by root 3 into VL, that is 3 into 10 to the power of 6 by root 3 into 4.4 into 10 cube. So finally we have the load current value, that is 393.64 amperes. So next, so in the problem they already given the synchronous reactance drop. Synchronous reactance drop is equal to 20% of the voltage, that is 20% of 2540.34, that is equal to 0.2. So 20 by 100 means 0.2. So 0.2 into 2540.34. So that is Ixs is equal to 0.2 into 254, 0.34. From this one, we will derive this equation as xs is equal to 0.2 into 2005 by 2.34 by I. In the just to calculate the I value, that is after simplifying this one, we have 0.2 into 2005 means 508.068 divided by I means 393.64, and finally we have the synchronous reactance value, that is 1.29 moles. So, but actually they are asked that determine the synchronizing power when 1 degree mechanical displacement. So that's why I am taking delta dash electrical is equal to delta dash mechanical into P, but that's why that actually the mechanical degrees is converted into electrical degrees. That's by using this formula, that is delta dash electrical is equal to P by 2 into delta dash mechanical. So in the problem they already given the number of poles is 6 divided by 2 into, so delta mechanical is equal to 1 degree, that is equal to 5 by 180. So substitute here 5 by 180 into 6 by 2. So after simplifying this, we have delta dash electrical value is 5 by 60 radians. So you know already the formula, that is synchronizing power P sub is equal to V square by Zs into delta dash. So that is use this formula, you use the formula, that is E into Is into delta dash. Use that formula also, you will get the answer. So here I am taking V square by Zs into delta dash. So that is equal to V means they are already given, that is 2540.34. This is for the phase, that is 2540.34 whole square by Zs is 1.29. So that into 5 by 60, that is delta dash is 5 by 60 radians. So that is equal to 2,61,934.44 watts. We will convert this into kilowatts, that is 261.934 kilowatts. This is the solution for the given problem. And next, coming to the sixth problem, that is a 2 MVA 3-phase star connected 4-pole 750 RPM alternator is operated on 6000 volts per bar. So here Xs, that is the synchronous reactance, is equal to 6 ohms per phase, and find the synchronizing power and torque at full load 0.8 power factor lagging. So here from the given data we have to calculate the synchronizing power and synchronizing torque for full load 0.8 power factor lagging. So from this one I am using the given data, that is rating of the alternator already given in the problem, that is 2 MVA, and poles also given, there is number of poles P is equal to 4, and the phases, it is a 3-phase star connected alternator. That's why I am taking phase is equal to 3, and connection is a star connection, and in the problem they already given synchronous speed, that is Ns is equal to 750 RPM, and they also given 9 voltage, that is equal to 6000 volts. This is for the 3-phase, and after that we will convert this into single phase, that is 6000 by root 3. Okay, next Xs is equal to the synchronous reactance is equal to 6 ohms per phase. So by using all this data, we have to calculate the synchronizing power and synchronizing torque. So here they given the power factor is 0.8. So from this one I am writing phi is equal to cos inverse of phi is 0.8. So that is equal to cos inverse of 0.8 is equal to 36.86 degrees. And from this one I am writing sin phi is equal to sin of 36.86 degrees, that is equal to 0.6. That means cos phi is equal to 0.8 and sin phi is equal to 0.6, and phi is equal to 36.86 degrees. So from this one we have to write synchronizing power. So this is for the 3-phase I am writing, that is P sub phi is equal to 3 into EV by Xs into cos delta into sin delta dash. This is one more formula to determine the synchronizing for 3-phase alternator, that is P sub phi is equal to 3 into E into V by Xs into cos delta sin delta dash. So you know already the cos delta value, cos delta value. So that is, so V phase is equal to, so actually in the problem they already given the line voltage, that is V phase, the V line is equal to 6000 volts. So by using that one we have to convert this line voltage into phase voltage, that is V phase is equal to 6000 by root 3. This is stock function, so I am taking this one 6 6000 by root 3, that is equal to 3464.10 volts. So in the problem they already given the KVA rating. So by using the KVA rating, we have to calculate the line current value, that is KVA is equal to root 3 into VLIL, this is the formula. And from this one I am writing IL is equal to MVA by or KVA by root 3 into V into IL. So in the problem they already given that it is a 2 MVA rating, that is 2 into 10 to the power of 6 by root 3 into line voltage is 6000 volts. So after simplifying this one we have 192.45 amperes. 192.45 amperes. And here I am drawing a phasor diagram for the armature current, induced EMF, and the drops, that is IRA and IXS. So reactance drop and armature resistance drop by using different angles. So here I am taking current as the reference, that's why I am taking current on the horizontal axis, that is IA as the reference phasor. And next in this one, the voltage E leads I by an angle, E leads IA by an angle phi, and next, so the result and V leads I by an angle phi. So here in this problem they already given, so E leads IA by an angle alpha and V leads I by an angle phi. Okay, so from this diagram we will write the equation, that is V bar is equal to V bar plus I bar into XS bar. So you know already I is equal to 192.45. So in the rectangle, in the polar form we will write this one as actually it is in the rectangle, that is J 192.45. So we will convert this into vector, that is I bar is equal to 192.45 at an angle of 0 degrees. And you know already V bar that is 3464.10. So here I am taking V bar is equal to 3464.10 at an angle of 36.86, and XS bar, so that is the synchronous reactance, that is equal to 6 at an angle of 90 degrees. Actually in the problem they given 6 moles per phase. So here we will rewrite this equation as XS bar is equal to 6 at an angle of 90 degrees. So you know you have all the values, that is V bar, V bar and I bar and XS bar. Substitute in this equation, that is V bar is equal to V bar plus I bar and XS bar. So V bar is the 3464.10 at an angle of 36.86 plus I bar is the 192.45 at an angle of 0 degrees into XS bar is the 6 into at an angle of 90 degrees. So after simplifying this 3464.10 at an angle of 36.86 degrees, it is actually in the polar form. And now we will convert this into rectangular form. And finally we have 2777.639 plus J 2777.981 plus, so 192.45 at an angle of 0 into 6 at an angle of 90. So actually these two are in the polar form. Please convert this into rectangular form. We have 1154.7 J. This is in the rectangular form of rectangular form. And next we will simplify this one. We have 2771.639 plus J 3232.68, and actually it is in the rectangular form. Please convert this into polar form. And after converting this into polar form, we have the value, that is 4258.19 at an angle of 49.39 degrees. Okay, this is the E bar value. So next, so from the diagram we will take E leads I by an angle alpha, that is 49.39, that is E value. So actually calculate the value, that is 4258.19 at the angle of 49.39 degrees. So in this one E value leads the I by alpha, that is 49.39 degrees. And next V leads I by an angle 36.386. So actually here the V leads IA by an angle phi, so that is 36.86 degrees. That is phi. And delta, so by we already know alpha and phi value. By using these two, we have to calculate the delta value, that is delta is equal to alpha minus theta. So here alpha is the 49.39 degrees minus pi value is 36.86 degrees. So after simplifying this, we have the delta value that is 12.53 degrees. So by using these all values, we have to calculate the total synchronizing torque, that is P suffix Sy is equal to 3 into E into V by xs into cos delta into sin delta dash, and we know already the value delta value, and by using that value we have to calculate the delta dash, that is already there is delta dash electrical is equal to P by 2 into delta dash, sorry, P by 2 into delta dash mechanical. So in the problem they already given number of poles is 4. So substitute here 4 by 2 into delta dash mechanical. Actually, if you take it is in the degrees, that is 1 degree, and if you take this is in the radius, that is pi by 180. So here I am taking only in degrees, that is the degree value is for the delta mechanical is 1 degree. So that's why 1 degree into 4 by 2, that is total we have 2 degrees. So that is equal to, the one that is P that is equal to 3 into E value is 4258.19. So that is this one, 4258.19 into V value is, they already taken, that is 3464.10 divided by 6. That is 6 is the number of poles, sorry, not the number of poles, it is the reactance drop, that is 6 ohms per phase, that is 6 into cos of delta value is 12.5 degrees into sin of delta dash value is 2 degrees. So finally we have the total synchronizing power, that is equal to 251.267 kilowatts, and by using this one we have to calculate the total synchronizing charge, that is equal to total synchronizing power divided by angular frequency, that is equal to 2 pi ns by 60. So by using the total synchronizing power and 2 pi ns by 60, we have total synchronizing power is 251.267 into 10 kV. Actually we have the value, that is synchronizing power 251.267 kilowatt. So we will rewrite this one as 251.267 into kilo means 10 cube, that is 1000 divided by 2 pi into. So in the problem they already given the speed, that is 750 divided by 60. So after simplifying this we have 3199.23 Newton meter. This is the synchronizing torque value for the given problem. Okay, so that is the solution for the problem number 6. And coming to problem number 7, so they given that a 750 kVA, 11 kV, 4-pole, 3-phase, star connected alternator has percentage of resistance and reactances are 1 and 15 respectively. So and calculate the synchronizing power per mechanical degree of displacement at first case is no load and second case is at full load, that to 0.8 power factor lagging, where terminal voltage in each case is given to be 11 kV. So that means in the problem they already given the line voltage, that is equal to 11 kV, and they given already that the number of poles P is equal to 4, and also given the rating of the alternator, that is 750, and it is a 3-phase, that is here the number of phases is 3. It is a star connected alternator, and next we have the percentage of resistance and reactance, that is percentage of resistance is equal to 1%. Actually it is equal to IR, resistance drop. The next percentage of reactance is equal to 15, that is reactance drop, that is I into XS, that is equal to 15%. So by using this data we have to calculate the synchronous power per mechanical degree of displacement at no load and at full load, both conditions. So here firstly we have to calculate the V phase value. So actually in the problem they already given the line voltage, that is equal to 11 kV. So by using that data we have to calculate the phase voltage, that is V phase is equal to 11 10 cube by root 3, that is 11,000 by root 3. We have the V phase value, that is 6350.85 volts, and already the formula KVA is equal to root 3 into VLIL. By using that formula we have to calculate the IL value, that is IL is equal to 750 kVA, that is 750 into 10 cube by root 3 into VL means that is 11 into 10 11 into 1000, that is equal to IL value is 39.36 amperes. And next, percentage of resistor drop is, that is IR drop is equal to IR is equal to 1% of V phase. So that is equal to 1% means 1 by 100. So that is equal to 0.01 into V phase. So that means R is equal to 1% of V phase. So IR is equal to 1% of V phase. By using that formula, we have to write R is equal to 1% of V phase by I. So that is 1% means 1 by 100, that is equal to 0.01, that into V phase is the 6350.85 divided by load current or line current is the 39.36, and finally we have the resistance, that is 1.61 ohms. And similarly, they already given the problem, that is the reactance drop, that is IXS is equal to 15% of V phase. So from this one we will rewrite this equation as XS is equal to 0.15, that is the 15 by 100, that is 0.15 into V phase by I. So here V phase is the 6350.85 divided by 39.36, that is the I value, that is the line voltage, line current value. And after simplifying this, we have the reactance drop, that is reactance value, that is 24.19 ohms. So here they given the two cases. At no load we have to calculate the synchronizing power, and at full load, that too at 0.8 power factor lagging, we have to calculate the synchronizing power, that is at no load. So the no load synchronizing power P sub SY is equal to V squared by XS into delta dash, V squared by XS into delta dash. So firstly we have to calculate the delta dash value, that is delta dash electrical is equal to P by 2 into delta dash mechanical. So in the problem they already given the number of poles is 4, that is 4 by 2 into delta dash mechanical. In the degrees means it is a 1 degree, it is equal to delta dash mechanical is equal to 1 degree. So I am taking 1 into 4 by 2, and finally we have the delta dash electrical is 2 degrees. If we want the radians, that is, if we want to take the radians, that is, so the delta dash mechanical is equal to 1 degree, that is equal to pi by 180. So please substitute pi by 180 in the place of delta dash mechanical. If we want to take this delta dash electrical into radians, so that is 2 into pi by 180, that is equal to pi by 90. And by using this, we know already the synchronizing power formula, that is V square by XS into delta dash. So just now we calculate the delta dash value, and now we have to calculate the synchronizing power, that is P sub SY is equal to V square, that is 6350.85 whole square divided by XS value is 24.19 ohms into delta dash value is pi by 90. And after simplifying this, we have synchronizing power, that is equal to 58.2 kilowatts. And for three phase, the total synchronizing power is equal to 3 into synchronizing power, that is 3 into 58.2 kilowatts, that is equal to 174.6 kilowatts. So this is a solution for the first case, that is at the low load. And coming to the second case, that is at full load, that too 0.8 power factor lagging. So in the problem they already given the cos phi, that is the power factor is equal to 0.8, and by using this we have to calculate the phi value, that is phi is equal to cos inverse of 0.8, that is equal to 36.869 degrees. And by using this we have to convert the sin phi, that is sin of 36.869 degrees. Okay, next they given as I value, that is I is equal to 39.36. So in the previous slide we calculated the I value, that is 39.36. So taken here, that is I is equal to 39.36 degrees, and V bar is equal to, that is V value is 6350.85. So taken here, that is 6350.85 at an angle of 36.86 degrees. And the reactance drop, that is XS is equal to, just to calculate that one, XS is equal to 24.19 ohms. So taken here at an angle of 90 degrees. Okay, here I am drawing the phasor diagram for this case. That's why here I am taking I as a reference phasor, and in this case E leads I by alpha degrees, and V leads I by theta degrees. And we have calculated the delta value, that is delta is equal to alpha minus theta, and we have the armature resistance drop and the synchronous reactance drop and impedance drop, that is IJ. Whereas in this phasor diagram, I have to write the equation that is E bar is equal to V bar plus I bar into XS bar plus IE bar into RA bar. So in the problem, they already given the V bar value is 6350.85 at an angle of 36.86 degrees plus I value is 39.36 at an angle of 0 into XS value is 24.19 at an angle of 90 degrees plus I value is 39.36 at an angle of 0 into 1.61, that is RA value. After simplifying this, we have the, so actually V bar is in the rectangular form, and then we have polar form, and then we have to convert this into polar rectangular form, that is 5081.33 plus J3809.63 plus, so 37.36 into 24.19 is 952.11 at an angle of 90 degrees plus 39.36 into 1.61 is 63.36 at an angle of 0 degrees. And after simplifying this one, we have 5081.33 plus J3809.63. So actually, the I into, sorry, the XS bar, I into XS bar is 4, and then we convert this into rectangular form, that is J952.11 plus the polar form is 63.36 at the angle of 0 for IRA. So please convert this into rectangular form. We have 63.36, okay, plus J0. So here, after simplifying this, we have the polar form of the above equation, that is 7007.24 at an angle of 43.51 degrees, and delta is equal to alpha minus theta. You know already alpha value, that is 43.51 minus 5 value is 368.86, and finally we have the delta value, that is 6.65 degrees, and we have to calculate the synchronizing force, that is P6SY is equal to EV by XS into cos delta into sin delta dash. So delta dash is decimal calculator, that is 2 degrees, that is E is 7007.24 into V is 6350.85 divided by XS is the 24.19 into cos of delta value is 6.65 degrees into sin of delta dash value is 2 degrees, and finally we have synchronizing force, that is equal to 63.771 kilowatts, and for a 3-phase the synchronizing force P7SY is equal to 3 into P7SY, that is equal to 3 into P7SY value, the synchronizing power value is 63.771, and finally we have the synchronizing power for the 3-phase is 191.31 kilowatts. So these are the different problems we are dealing with the parallel operation of alternators. For all the concepts, these problems we have, and now this is the third unit, that is parallel operation of alternators, and in the next class I am going to discuss the fourth unit, that is synchronous motors. Okay, thank you for watching this video.